All right, in this video we're going to continue our lesson for lesson 2.9, but in this one we're going to be looking at how to solve equations involving absolute values, and we'll also be looking at how to solve inequalities involving absolute values in the same video. Now, some things to think about though in regards to solving absolute value equations is that they could involve one of three different scenarios. Remember, an absolute value equation would just be, our absolute value would be the shape of the V. So when we're solving an absolute value equation, like this one here is the absolute value of x plus 2 equals 4. We could look at this as a system of two equations, one with the absolute value on the left, and the graph on the right, the red line, would be the line y equals 4. So what we'd be looking for is the solutions. Where do they intersect at? For what values of x do they intersect at? So for this one, your answers would be where x is 2 and where x is negative 6. So we'd have two solutions there. But we don't always have to have two solutions. Sometimes we could have just one solution. If you look at this one, here we have, again, the absolute value of x plus 2. That's the blue line. And then the right side of the equation is 7/3 x minus 2. And we only have one solution. So that would be that the only time that they intersect at is where x is 3. And sometimes you'll have the graph and they won't even intersect. So there's no solutions at all, which would be the case for this one. Now, we are not going to be solving these graphically. We're going to be solving these algebraically. And so when you're solving them algebraically, you're oftentimes going to get an answer that's what we would say is extraneous. It's not going to be a solution that actually works in the problem. And we're not going to know that unless we test it out. So when solving algebraically, it's important to check your solutions because, again, you're always looking to see, is there an extraneous solution, a solution that does not exist. So it's not that you did anything wrong in the equation, in solving the equation. It's just that one of the answers won't work. Sometimes. So let's look at this first one. So this first one, we have the absolute value of 5x plus 2 equals 27. So how do we solve an absolute value equation? These are also going to be a little different because they're not a normal equation. If you think about it, we're trying to figure out what are the numbers whose absolute value would be 27. So I'm trying to figure out what numbers could I put inside of that absolute value, ignoring that there is an expression inside of there, trying to figure out what numbers we'd put inside there. Well, if you think about it, there's actually two solutions, 27 and negative 27, because the absolute value of 27 would be 27, and the absolute value of negative 27 would also be 27. So there's going to be two solutions. So we need to find out what values to put in for x that would give us those two solutions. This is why we will always work with two equations after isolating the absolute value. Make sure you get that in your notes, the last two sentences there. So we're going to have two equations that we're going to set up because my goal is to try to figure out what's going to go inside of that absolute value. What values for x, rather, would I put inside of there that would give me 27 as my answer, and what numbers I can put inside of there that would give me negative 27 as my answer. So again, if you need to write this down, if you don't have it all in your notes, pause this video before I move on. All right, so again, we know that this piece here has to either be 27, has to either be 27, or we're trying to figure out what value for x would give us negative 27. So there's going to be two equations to solve. So when I solve that first one, I would subtract 2 from both sides. And by the way, when you write it as two separate equations, you don't include the absolute value anymore. So please do not leave the absolute value in there anymore. It's done after we separate it out into two separate equations. So the first one, I would subtract 2 from both sides. Now I would have 5x equaling 25. Then divide by 5, and we would obviously get one of our solutions is 5, or could be 5. And now I'm going to do the same thing the other side. I'm going to take and subtract 2 from both sides. When I do that, I get negative 29. And when I divide both sides by 5, I get negative 29 over 5. So that would be my other solution. But we got to check both of them because I know I didn't make a mistake here, but I need to check to see do these both simplify to be the absolute value of 27. So let's try the first one. So in the first one, if I put 5 in there for x, 5 times 5 is 25. 25 plus 2 is 27. Sure enough, the absolute value of 27 is 27. So that one checks off. That one works out. The second one, if I put negative 29 fifths in there, now 5 times negative 29 fifths, well, the 5s would cancel out. If I had this, these two 5s would cancel out, leaving me with negative 29 plus 2, which is negative 27. but it's the absolute value of negative 27, so that gives me 27 when I simplify it. Sure enough, that equals 27 on the right, so that also checks out. So those both check out, so this would be one where we have two solutions. Let's look at the other one. Now, before we do anything with changing the equations or anything like that, we need to get the absolute value by itself. So I'm going to add 9 to both sides. And so when I do that, I'm going to squeeze this in. Can I squeeze this in over here? Let's see. I would have 1/2 x minus 1 equals, when I add 9 to both sides, I would have negative 5 plus 9, so that would be plus 4. So now my two equations I'm going to have, I would have 1/2 x minus 1 equals x plus 4 would be one of them. The other equation is going to be 1/2 x minus 1 equals a negative. Now there's two ways I could write it. I could write it like this to say it's going to be the opposite of the entire equation, but I'm going to just distribute that negative through. When I do that, I would have negative x minus 4. So make sure that you distribute the negative through. Don't just apply the negative to the first term. It applies to everything, so both the x and the 4. So now I'm going to solve both of these as two separate equations. So the first one, I'm going to multiply everything by 2. I'm going to clear out the fraction. Even though there's only one fraction, I'm going to multiply everything by 2 just so I can get rid of the fraction. So 2 times 1/2 would just be 1, so I'd have 1x, or just x. Distribute the 2 through now, so x minus 2 equals 2x plus 8. This is going to be more manageable now, so I'm going to subtract x from both sides. So in that way I have keep my x's positive. If I subtract x from both sides, I'd have 2x minus x, that'll be x on the right. Subtract 8 from both sides, now I have negative 10 equals x. So that's one of my possible solutions. Remember I said possible there. Let's look at the other one. So I'm going to multiply again, just like I did on the previous one, everything by 2. So now I'd have 2 times 1/2 would just be x. So I'd have x minus 2 equals negative 2x minus 8. This time I'm going to add 2x to both sides. So now I'd have 3x. And then minus 2 equals negative 8. Add 2 to both sides, and I would get 3x equals negative 6. Divide both sides by 3, I get x equals negative 2. So now I want to check, and by the way, when we check, we always want to go back to the original equation. So you don't want to go back and check with anything that we did, that we changed, because what if we made a mistake when we went and changed any of this? So you always want to go back and check this with the original equation. So I'm going to put negative 10 in there for x, and so I would have the absolute value of 1/2 times negative 10 minus 1 minus 9. I want to see if that's equivalent to negative 10 minus 5. So when I do that, half of negative 10 is negative 5, minus 1 is negative 6. So the absolute value of negative 6 is a positive 6. And so I'd have 6 minus 9, which would be negative 3. And on the right side, I get negative 15. Those don't equal each other. So x equals negative 10 is not a solution. Let's try the other one. So we would have 1/2. Let's see if I can squeeze this in. So we'd have negative 2 minus 1 minus 9. I want to see, does that equal negative 2 minus 5? Just barely got that in. So I know the right side is going to be negative 7. Let's see what the left side is going to be. So half of negative 2 would be negative 1. Negative 1 minus 1 is negative 2. But the absolute value of negative 2 is a positive 2. And 2 minus 9 would be negative 7. So sure enough, I get negative 7 equals negative 7, so that one checks. So my only solution for that second one is x equals negative 2. So again, it's very important you check your answers. If you don't do that, and if you say that your solution here would have been x equals negative 10 and x equals negative 2, you'd lose points. All right, let's see how you're doing with this. I want you guys to go ahead and try these two on your own. So pause the video. If you notice, both of the absolute values are already isolated. They're by themselves, so you just need to set up your two separate equations. So go ahead and give these two a shot and hit play when you're ready to check to see if you've done them correctly. All right, let's see how you did here. So again, for this first one, we'd have x plus 6 equals 2x plus 8 would be one equation. The other equation would be x plus 6 equals, and I'm going to take the opposite of both those terms. Remember, we distribute the negative, because you'd have a negative times 2x plus 8. So I'm going to distribute that through to get negative 2x minus 8. So now let's go ahead and solve these. So the first one, I'm going to subtract x from both sides. Oops. So when I take it, and I always do that, I always like to subtract the smallest variable, so that way I can avoid negative numbers. which is going to be useful when we work with inequalities. And then, so I would subtract x from both sides. So on the right side, 2x minus x would be x. On the left, I'm going to take 8 and subtract that from both sides. So on the left, I'd have 6 minus 8, which is negative 2. So one of my solutions could be negative 2. We'll test that out here in a second. And then on the right side, or on the other equation, I'm going to add 2x to both sides this time. So because minus 2x is smaller than x. So now I get 3x, and I subtract 6 from both sides, and I get negative 14. So I would get x equals negative 14 thirds. Now you should have checked these. So for this first one, when you check that one, you'd end up getting 4 equaling 4, because negative 2 plus 6 is negative 4, but then the absolute value of that is 4 on the right side. Negative, or 2 times negative 2 is negative 4, and negative 4 plus 8 is also 4, so that one checks out. The second one is a little trickier, so let's do that one. So if I had the absolute value of negative 14 thirds plus 6, I'm going to change that 6 to be 18 thirds, because in that way they have a common denominator, because 18 divided by 3 would be 6. And on the right side, we would have 2 times negative 14 thirds. And again, I'm going to change that 8 to be 24 thirds, because 24 divided by 3 would be 8, so then we're going to have a common denominator. So on the left side, negative 14 plus 18 would be 4, so we'd have the absolute value of 4 thirds, which is just 4 thirds. And on the right side, I'd have negative 28 thirds plus 24 thirds. And when you add those together, we get negative 4 thirds. Those are not equal to each other because they're not both positive or not both negative. So this is not one of our solutions. All right, so let's try the last one. So the last one, I'm going to have 2 equations, 2x plus 5 equaling x plus 7, and 2x plus 5 equaling a negative x and a negative 7. So for this one, I'm going to start by getting all the x's on one side. So I'm going to subtract x from both sides, giving me x. On the right, I'll subtract 5 from both sides, giving me 2. So I get x equals 2. That's one of my possible solutions. Over here, I'm going to add x to both sides. So we'd have 3x. And then I'd subtract 5, and I would get negative 12 on the right. So when I divide by 3, I get x equaling negative 4. And when you try both of those, they both end up checking out. So both of those are feasible solutions. All right, well, let's talk about inequalities. Okay, this is the last thing we'll do in this part of the video. So to solve inequalities, when writing the second inequality, that is the opposite of the original, we need to flip the inequality, because essentially what we're doing then is we are multiplying by a negative. So again, we don't do that. We don't write our 2 separate equations until after we get the inequality by itself. So for this first one, we're going to have 5 minus 2x, the absolute value of that. I would add 4 to both sides and get 13. Okay, so now this is where we're going to write this as our 2 separate equations. So one equation will be 5 minus 2x is greater than 13. The other one will be 5 minus 2x. Then we're going to make that 13 a negative, so we have to flip the inequality as well. So now we're going to solve each of these. So for this first one, I would subtract 5 from both sides. So when I do that, 13 minus 5 would be 8. So we'd have negative 2x is greater than 8. So you can see that I'm going to have to divide by negative 2, which means we flip that inequality again, and then we would get negative 4. So we get x is less than negative 4. For this one, oops, I forgot my x. For this one, I would subtract 5 again, so we'd have negative 2x is less than negative 18 when I subtract 5 from both sides. And when I divide by negative 2, we have to flip the inequality again, and negative 18 divided by negative 2 would be positive 9. So when we're working with these, again, sometimes it's easier to draw a number line. So we're saying it's going to be less than negative 4, but the solutions are going to be also great, or could also be greater than 9. So our solution set, we would say go from negative infinity to negative 4, and from 9 to infinity. So that would be your solution set for this one. Now let's try this last one together. So in this last one, we're going to, again, the absolute value's already been isolated, so we don't have to do anything there. So I'm going to set up my 2 separate equations. So I'm going to have one that's going to be x plus 2 divided by 3 is less than or equal to 2. And the other one's going to be x plus 2 divided by 3. Since I'm going to change that 2 to a negative, we have to flip our inequality. So it's going to be greater than or equal to negative 2. So now let's solve that first one. So to solve the first one, I'm going to multiply everything by 3 to get rid of the fractions. So we'd have x plus 2 is less than or equal to 6. So we cleared out the fraction by multiplying by 3. If you didn't see what I did there. And so now we would just solve this by subtracting 2. So we get x is less than or equal to 4. The other one, we're going to start the same way. We're going to multiply everything by 3. So we would get x plus 2 is greater than or equal to negative 6. But we didn't multiply by a negative, so we don't have to flip the inequality here. And so now I would just subtract 2. So we would get x is greater than or equal to negative 8. So look at what happens on this number line. So we have negative 8 would be down here, 4 would be here. So the solutions are going to be less than or equal to 4, but they're going to be greater than or equal to negative 8. So for this one, my solution set would go from negative 8 to positive 4. We use brackets there because the endpoints are included. So this would be your solution for that second example. So that's why, again, it's so important to use a number line because it gives you that visual so you know if your solutions are in between the two values or if they're outside the two values. All right, so there's only one that I'm going to have you guys try. So why don't you guys try this one on your own? So why don't you pause the video and then try it and hit play when you're ready to check to see if you've got the correct answer. All right, so the first thing we got to do is you should have gotten the absolute value by itself. So we want to isolate the absolute value. So I would subtract 4 from both sides. That would give me 5. So now what I'm going to do is I'm going to write my two separate equations, or my two separate inequalities rather. So we would have 5x minus 3 divided by 5 is going to be greater than or equal to 5. Then we would have 5x minus 3 divided by 5 would be less than or equal to negative 5. So we're going to solve these both the same way. I'm going to start by clearing the fraction by multiplying by the denominator, the 5. So then on the left side, that stays 5x minus 3. On the right side, we multiply that times 5 to get 25. Same thing. Well, I guess we'll do that in a second. So now we're going to add 3 to both sides to get 28. And then we would just say x is greater than or equal to 28/5. Going back to this one, we multiply everything by 5 like we did. So we'd have 5x minus 3 is less than or equal to negative 25. Add 3 to both sides, we get negative 22. Divide by 5, we get x is less than or equal to negative 22/5. So it's okay, even though it looks weird that we have two fractions. If we were to put this on a number line, we'd have negative 22/5. It's going to be everything less than or equal to that value. And then we'd have 28/5. Everything's going to be greater than or equal to that value. So this one, your solution set, we would say they go from negative infinity to negative 22/5. And then they'd start again at 28/5 and go to infinity. So hopefully you got that. If you did, great job. And that is the end of this video where we're looking at working with absolute value.